right. Good day, students. Today I am here to teach on lesson 4.1, and this will be the second day that we will be spending on this unit. Today we're going to be talking about angles and their measures and specifically focusing on two objectives. Those two objectives are converting between radians and degrees and understanding the difference between radians and degrees. Really, converting between radians and degrees is like a unit conversion, and understanding the difference between them is the really important thing that might seem difficult at first, but really tune in and I think it'll start to make some sense. We'll also be using our graphing calculator today, so make sure you have that handy so that you can know how to use that tool as well. Let's get started. Today we're going to be talking about degrees versus radians. And I have a little picture here as well as some key facts that help us better understand the difference. So on the left-hand side, we have a degree measurement. A degree measurement is often associated with the observer's viewpoint. What that means is you're really focusing in on what's happening at the origin or the angle in the middle. I just highlighted it in yellow. That's going to be kind of the picture of what you might see there. Now, when you're talking about radian measurements are going to be the mover's viewpoint. So it's like taking this outside part, putting it in a straight line and saying, this is that measurement. Okay? So let's take a look at some relationships between them. A degree is always represented with the degree symbol. Most of us are familiar with that. A degree is equal to 1/180th of a straight line. So a straight line or horizontal line is 180 degrees. So 1 degree is 1 out of 180. And sometimes we'll get more specific with degrees, minutes, seconds, but this year we won't be using degrees, minutes, seconds. We'll just be using decimal values. A radian measurement, again, is the mover's viewpoint. So it's like if you're walking around the angle, what would you see there? Now, with a radian measurement, we're always going to use the word radian, or we'll exclude the degree symbol. So if the degree symbol is not listed, we're going to assume that that is in radians. Oftentimes, it has a pi symbol involved with it, and that connects to the fact that a circle around the outside is calculated by, or use the word circumference. And so to find the circumference of a circle, we have 2 pi r. And so that's where that pi symbol comes in. It has to connect with the circumference of a circle. Okay. And then last but not least, pi radians, or halfway around the circle, is considered to be equal to 180 degrees. This is part of our unit conversion, which we'll talk about next. So in order to convert between radians and degrees, we are going to be using this conversion. So if I am converting radians, so starting with radians and ending up in degrees, we are going to use this multiplier. Really what we're doing is we're putting the radians in the denominator of our unit conversion, and that's going to allow for the radian measurement to be eliminated, and we'll be left with our degrees. And then to convert the reverse direction, so from degrees, if we start in degree mode, then we can convert it to radians by multiplying by pi radians over 180 degrees. Now, I thought I'd explain this a little bit more with our circles. So oftentimes we're going to use a radius of 1. We call it a unit circle. And so therefore, if I found the circumference of this unit circle using our formula 2 pi r, we would know that the circumference is 2 pi. That means that if I went all the way around the circle, I would have traveled, remember, radians is the mover's perspective, I would have traveled 2 pi radians. That means that if I would have stopped here at 180 degrees or halfway around the circle, I would have been half of 2 pi. Therefore, 180 degrees is equivalent to pi radians, which is why we say that our unit conversion is 180 degrees over pi radians. Let's move on and take a look at some examples. So our first example is going to be converting 90 degrees into radians. So in order to do this, I usually start with a unit fraction. So if I'm given a degree measure that doesn't have a denominator, which typically will happen, I just write it over 1. And then remembering that we have that relationship, pi radians is equal to 180 degrees, I'm going to put 180 degrees in the denominator and pi radians on top. What this is going to allow for me to do is it's going to allow for the degrees to divide out, and I would be left with 90 times pi over 180, or pi over 2 radians. Now, as we move through things, you're going to see that this is going to be a very common measurement that we use, and one that you'll be wanting to be very familiar with. Go ahead and try the next one. I'm going to also start up that next one, so go ahead and follow along. So again, starting off with 28 degrees, I always write it as a fraction. I just think it's easier to process. And then I want to put the degrees in the denominator because I want the degrees to cancel out or divide out. So degrees are gone, and I'm left with 28 pi over 180. Now with these radian measurements, we are going to always want to simplify the fraction. And so maybe that's something that's a little difficult for you. So I'm going to just go ahead and show you how to use your graphing calculator for this. Remember that the key history is located below the screen. And so we have 28 divided by 180. I will exclude the pi symbol because we'll leave that in our answer. And then I can hit math. And the very top option is fraction. So this is going to allow me to convert this into a fully reduced fraction, or 7 over 45. So when I do this, I would get 7 pi over 45, and that would be my radian measurement, or my answer would be in terms of radians. All right, let's talk about converting in the reverse way. So in example 2, we're going to be converting from radians to degrees. Oftentimes, our radian measurements are going to start with a fraction, which is really great because it makes it easier for us to already have a fraction to work off of. Now in this case, I have labeled it as radians, but remember, if it's not labeled, we assume it's in radians. And then we're going to go ahead and multiply it by its conversion. Well, we want the radians to be on the bottom. Remember that right now the radian measurement of 3 pi over 4 would be on the top. And pi radians is equal to 180 degrees. So the radians would divide out, again, using that idea of unit conversion. And then I'm going to just do this math. Now, when I do this math, I have 3 times 180, which is 540. And I still have that pi symbol attached. And on the bottom, I have 4 times pi, which is 4 pi. Now, the label that will carry through is degrees. Now, be careful. Always go back and see if you can simplify. In this case, the pi is the same on the top and bottom. And then if I go to my calculator and I finish solving this, I'm going to find that this equals 135 degrees. This is another one of our very common measurements that you're going to see showing up as we continue our study around the unit circle this week. The next example we have is converting pi over 3 radians into degrees. So again, I'm going to go ahead and start with pi over 3 radians, and I'm going to multiply it by a fraction. I want the radians to divide out, so I'm going to put radians on bottom and degrees on top. And there are 180 degrees in pi radians. Remember, a unit conversion is simply something that is equivalent to each other. 12 inches in 1 foot is another example of a unit conversion. So now that we've done this, I can see that the radians will end up dividing. Sometimes students will cancel the pi's out here. That's totally acceptable as well. And we end up with 180 over 3, which simplifies to equaling 60 degrees. Yet again, 60 degrees, or pi over 3 radians, is a very common measurement. So it's one that you'll get very familiar with the unit circle. All right, let's move on to just talking a little bit more about the calculator, and then we're going to practice typing in some components to the calculator. So one of the biggest things that students struggle with is figuring out how to change it between the different modes. So how do you change between radians and degrees? You're going to be using the mode button. So the mode button is located right over here. And I'm actually going to grab my concrete calculator here. So my mode button is located right here. And then you'll see this screen, and the 1, 2, third option down is radians and degrees. So again, the mode button, I'm going to circle it here, is right here. This button. And when you click on that button, you'll see this screen. On this screen, we are specifically looking at this line right here. The dark highlighted one says radians under it. It's just hard with the way the screenshot was. And then the degree is the other option. So depending on what you're evaluating, you may need to switch it between the different modes. Now, the next common question we get as teachers is, how do you know which mode to be in? Well, you'll want to pay attention to if there is a degree symbol. So if you have your degree symbol, you're in degrees. Symbol. That's that little circle. You want to be in degree mode. If it's not labeled, we assume radians. So otherwise, radians is used. Again, oftentimes radians are going to be labeled or have a pi symbol in them. But again, that doesn't always have to be the case. So just be careful. So let's go ahead and jump over here to learning how to evaluate these different values on the calculator. So right off the bat, when I'm doing these types of problems, I like to just make a note of what mode I should be in. So in this case, I see my degree symbol, so that's going to tell me be in degree mode. And then I don't see it here, and I also see that they both have pi's in them. So this is going to be a radian measurement problem. And this is also going to be one where I want to be in terms of radians. Next, I'm just going to grab my calculator and I'm going to evaluate these. So in my calculator, the first one was in degree mode. So I'm going to click over the top of degree and press enter. And then I can go out, and it was tangent of 8 degrees. So I'm going to type in tangent of 8, closing my parentheses, and I get an answer of 0.14. So over here, all I did was type it in, and I got an answer of 0.14. Now, on your homework, be careful to always read the directions. Sometimes they have you use different measurements. The next one, we're going to find cosine of pi over 10. Now, because this one is in terms of radians, I'm just going to switch my mode over to radians. Second quit is going to allow me to come out of that, and I'm going to type in exactly as I see it. So cosine, second caret, that gives me my pi symbol, divided by 10. Closing my parenthesis and pressing enter gives me an answer of 0.95. Now, as we go this week, you're going to learn more about what these mean. But remember that all of these different values are simply measurements around the unit circle. So it's going to be that ratio of the, in this case, adjacent over the hypotenuse. If we had created a triangle, a right triangle, That's what we're essentially finding. We're also going to make some more connections with the unit circle as we go. So just continue to fully engage. It's going to help you long term. The last one is pi over 15. Again, we're in radian measurement. So I'm going to jump over to my calculator and type that in. So I have sine second caret, put that pi symbol in, divided by 15, closing my parenthesis and pressing enter. Remember, we had already switched our calculator to the radian mode, so we didn't have to switch it back. In this case, our answer is 0.209, which, because of simplicity, I'm going to round to 2 decimal places or the nearest hundred and give an answer of 0.21. So that's it for today's lesson. Again, focusing really in on what is a radian versus what is a degree. It's really your different viewpoint. So an angle measurement is from the inside part, and a radian measurement is like the walking distance, or your observer, your outside distance. And then learning how to convert and evaluate different quantities on the calculator. I hope today's lesson made sense, and we'll see you soon. Bye.